So now, okay, is it visible?
Yes.
Okay. So now we can start. Okay, so first we will start the discussion with the degrees of freedom. Okay. So what does it mean, the degrees of freedom? So or DOF. So this definition basically comes from this degree of freedom definition comes from the normal mathematical equation, you know. So let's say I'm saying if you have two independent variable x and y, or let's say three independent variable x, y, and z. Okay, so these things we have already discussed a little bit, but in a different viewpoint. Okay, so in among these three independent variable x, y, and z, if there is one restriction, what is the restriction? Let's say I'm saying x plus y equals to z. This restriction I specially consider. So in that case, what will be our number of independent variable now? These are three variables right now.
Two.
Yes. But if I ask the independent variable, then it will be 3 minus 1 equals to 2. 3 minus 1 means this is essentially total variable minus constraints. How many constraints are there? Not constant, constraints. Any constraints constraints it may be like that. Here x plus y equal to z. Okay, how you can understand this? Let's say x and y you can choose x equal to 5, y equals to 3, but now you can't choose z because due to that constraint automatically z will be 8. So essentially you have two independent variables. So this is the degrees of freedom. That means how many degree of freedom you have. You have two here. You can choose two independent variables. So these things are essentially the same. In because here it is variable, that's why it's independent variable. But it essentially represent the your degrees of freedom. So here your degrees of freedom are two. Okay. So essentially, this is the definition of degrees of freedom. And now, depending upon the system or context you are talking about, this definition will be same, but the relation, the equation, this will be different. But in general, if you say in general, the definition of degrees of freedom is this total freedom, not freedom variable, minus this restriction or constraints, whatever you want to. Constraints is right.
Two I can select as I want.
But huh, huh,
These
huh.
two
If
variables.
there is two constant, then there will be one degrees of freedom. If you
I
have
can
three
choose
constant,
X and Z.
yes, any two, any two. That is not mentioned here. You can choose here any two. If you choose X and Z, then obviously Y will be fixed automatically. That's why it's called degree of freedom, na? Because it's up to you. Which two you have to choose? You have two parameter to choose. That's why degrees of freedom is two. Okay.
Okay.
Or before in equipartition also we have used this concept of degrees of freedom. There also, if you remember, the concept is same. In the equipartition case, okay, let me reconnect it.
But there was translational, rotational, vibrational degrees of freedom.
You have to consider different motion. That's it. When it is, let's say, translational, there is no restriction, na? So there are three directions are available. Here also the independent variable, in terms of independent variable, you can choose. The 3 degrees of freedom are available here. X, Y, and Z. Okay. For rotation also, but the constants appears where in case of vibrational, because there you know why 3n minus 5 is appearing, because there is a restriction of total degrees of freedom should be 3n.
Yes.
That's the case. Hmm. But that is a different, uh, I can say different from this perspective. But here, in case of phase rule, it's totally identical. This um, phase rule, degrees of freedom, phase rule, these things are totally identical. So that part we will discuss today. Okay, let me open it now. I think degrees of freedom is clear. Now, in case of phase rule, this modifies, this definition actually modifies the degrees of freedom DOF equals to, or F also, it can written as F. F is equal to C minus P plus 2. Okay, where C is number of component, P is number of phase. Okay, and if you want to see the proof, this proof is also very nice proof. I can say it's a little bit complicated, but it's very much straightforward, this proof. So you can check it in any textbook, you will find it, but it's not very difficult. Okay, but for time being, we can consider this is our C minus P plus 2, because I am not doing this proof because this proof is very lengthy, not difficult, but it's lengthy. You have to rewrite it, so many things. So it's better to read it from any textbook. You will understand it. It's very easy. But this is C minus P plus 2. Now, you have to understand what is the component and what is the phases. These things is very difficult. Not difficult, confusing, you can say. So, what is the phases? Phase means you can differentiate phases by physical understanding, by seeing, by physical experiment. These are called phase, like liquid, solid, vapor. These are phases, right? In upcoming example, we will see. While solving various example, it will be clear. Okay, but what is a component? This is not very easy actually. Component and the okay. Before that, we should discuss some example. Then it will be clear, because this component, definition of component is actually C equals to C minus R. Okay, C prime minus R. So what is C prime and what is R? So that is, we need to understand it. Okay, R is restriction, and this C prime is actually the you can say the chemical species that is present in the system, like that. These things will be clear when we'll solve a few examples, then it will be clear. Okay. So let us discuss some example, then it will be very much clear. Okay. So question number 2, calculate the number of phases, components, and the number of degrees of freedom in the following systems. Okay, I will write the system and you can try. Then I will discuss. So the first one. Okay.
Okay.
So now try to calculate. It might be wrong, but right.
Component is 3, phase is 2, and degrees of freedom is 3.
Okay. Let us check. Okay. So let always start with phase. So how many phases are there? Solid
2,
and gas. Solid and gas two. Exactly. So and what is the number of components here?
3.
3 minus 1. 2. This restriction you have to understand. This is a restriction.
What is this?
This is the equilibrium. That means actually if you have only two species, then automatically this will produce, right? So this is not a different species right now. You have to understand like this.
Okay, it is like the equation. Yes, okay.
It's like the equation C minus R, C prime minus R. So effectively C is 3 minus 1, 2. So now you can calculate degrees of freedom, which will be 2. Okay.
What is the significance of this degrees of freedom?
Okay. So you see, here the degrees of freedom is in the phase rule. Okay. That means pressure and temperature. Phase diagram you remember? Okay. Please ignore that because, okay. Uh, you have how many variables you know? P, V, T.
Yes.
But in case of phase diagram, we actually discussed the PT plot, PT diagram, right? So here pressure and temperature. So here for having this reaction, that equilibrium, you can choose any arbitrary pressure and temperature. There is no restriction. Two, only two. Pressure and temperature, degree of freedoms are two. If there is only one degrees of freedom, you will understand right now. But here it's clear that two.
Yes, and how can I find the restriction?
Here you can see the restriction.
When the equilibrium sign, there is restriction 1.
Any kind of restriction it can be. Any kind of restriction. Just look at this question, you will understand that above reaction, above equilibrium. So equilibrium is a restriction. when this, now you calculate what will be the degrees of freedom or the phase or the components.
Phase is 2,
Phase will be anyway 2 because that is not changing.
component is 1,
Hmm. So phase is 2, component is actually C minus R. So here 3 minus 2, two restrictions are there. One was already there due to this equilibrium. Another one is this. So eventually one restricts, one components. Therefore, degrees of freedom will be C minus 3 plus 2. So it is 1. So you see, only temperature you can choose now because I have already fixed that partial pressure should be same. Okay.
so I cannot choose the pressure.
No, that is a restriction, degrees of freedom. So you can't choose the partial. Yes, because now for having equilibrium, for a particular equilibrium, there is a relation of partial pressure. And you have to fulfill that P equal to NHC equal to P equals to P equal to HCl. Okay. So that means
Okay.
to obtain the equilibrium, you can only choose one pressure. Okay. So in that sense, you can see you have only 1 degrees of freedom.
Okay.
Okay. In that way. Here, for having the this equilibrium, when the partial pressure is not the same, just you write down that Kp. What will be Kp? That partial pressure of
NH3 plus
NH3, partial pressure of HCl. If it is balanced, it is
partial
balanced
pressure of
here.
NH4Cl.
Partial pressure of NH4Cl. And now this partial pressure NH3 and HCl should be equal. And
Yes.
Kp is always a constant for particular reaction,
Yes.
for particular temperature, obviously. So that means if you choose the temperature, you essentially constant the Kp. When you essentially constant the Kp, so you there is no other option. The pressure will be only one. Okay.
Okay.
So anyway you will have only 1 degrees of freedom. I think it's clear.
Yes. Yes.
So just see one restriction is arising due to the equilibrium, which is given by the temperature. That is 1 degrees of freedom. When you fix the temperature, automatically you are fixing the Kp. Okay.
Okay.
And when you fixing the Kp, that means it is if at equilibrium, Kp should be equals to this. That is giving a restriction that equals to, let's say, I'm just saying, let's say at a particular temperature, 300 Kelvin. With this example, I think it will be very much clear. Let's say I'm just saying Kp is equal to 1, 2. Then P of NH3, P of HCl should be 2 of partial pressure of NH4Cl. Okay.
Okay.
So this is one restriction. How it is appearing? This is appearing due to this equilibrium.
Yes.
Because anyway, Kp should have some value at a particular temperature. Now, this is one restriction, and another restriction is PNH3 equal to PHCl. So that means this is the square. So two restrictions are there. So you have only 1 degrees of freedom. Okay.
I can choose only one pressure.
Yes. Automatically other pressures will be constant. Not constant, defined. Okay. Okay. Um, okay. So degrees of freedom, I think it's clear. When you choose one temperature, uh, temperature or pressure only you have to understand like this. When I will discuss the phase diagram, it will be very clear, I think.
Equilibrium is one restriction, and every equal sign is a restriction. Temperature,
Or any
pressure.
other condition. It may not be written in the like this. It can be stated. You have to understand the restriction. Just see this reaction. Now guess it. Just write.
Phase is 3, component is 0, and degrees of freedom is -1.
Okay. Degrees of freedom can be -1.
It cannot be -1 if the statistical thing.
Is always greater equals to 0. Degrees of freedom is always greater equals to 0. So from because this is freedom -1, how it can be? So C minus P is always greater equals to 2. Or you
Here
can say
component is only 1.
no. Okay, let us check. Phases. How many phases are there?
3.
How?
One is solid, one is in water, and one is in benzene.
Exactly. Water and benzene is actually immiscible because water is polar and benzene is
Benzene is
non-polar
non-polar.
solvent. That's why it creates two different phase. That's why it's phase means both are liquid. That means same phase. That is not true. Phase means that you can identify it by its physical properties. That's why it is a different phase. So benzene and H2O. Now components. C prime is very clear. What is C prime?
1.
How?
Only iodine.
No. Why only
Water and
iodine?
benzene are also component.
Water and benzene are also not component, but iodine in water and iodine in benzene are different. Okay.
Component means it is a chemical.
No, 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 no. Component means it's a chemical thing. Okay. But in iod, okay, just understand like this. When you are using iodine in water, that iodine, structure of that iodine is not the same as the normal iodine. Okay.
Structure of iodine is different.
Okay. You can think like water and benzene. If it is works for you better, then you can consider. Just I am saying like this. It will it will be like this, na?
In water.
In water. So in benzene, it will be different. So cumulative structure will
Yes.
be different. So better you can choose is three. Just consider water and benzene. If it is easily understandable, then it's okay. The same thing. Ultimately, the meaning is the same. And what is the restriction? How many restrictions are there?
1.
No. Here is no restriction.
Here is equilibrium sign.
That's why it's important. It's called pseudo equilibrium. Okay. It's how it can be equilibrium between same substance. You have studied the equilibrium. Is it a chemical equilibrium?
No, it should not be.
It should not be. It's a pseudo equilibrium. So the chemical equilibrium only be considered because we are considering the chemical components. Okay. If you have solid iodine, just understand like this. It's not that much complicated. I am just want to discuss variety types of question with the exceptions. That's why. Otherwise, these exceptions are very rare to ask. Very rare.
It is phase equilibrium.
Just understand like this. If you have solid iodine, what does it mean? Normal chemical equilibrium. That means it's a dynamic thing, right? A to B.
Yes.
A B equilibrium means if you have A, automatically B will be generated, and after sometimes when it is reached the optimum value concentration, the equilibrium often. That is the funda. But here, if you have only solid iodine, how solid iodine can be iodine in water and iodine in benzene? Is it possible?
No.
It's not like that. But here, if you see, if you have just normal NH4HCl, NH4Cl solid, automatically NH3 gas and HCl gas will be there, or the vice versa.
Yes.
Okay, so that's why it's a chemical equilibrium, but it's not. How it is obtained? You have a iodine, solid iodine in beaker, and you just put water and then benzene, and then you are trying to mix. It's like that. It's a physical equilibrium. You can think it's not chemical equilibrium. Okay. So that's why
Okay.
it's called pseudo equilibrium. In case of pseudo equilibrium, obviously there is no restriction. You you have to understand the meaning of restriction here. Why it's a restriction? Because there is a Kp. Oh, I just erased that. Due to that equilibrium. That means
Oh.
if you have NH3 HCl, automatically NH4Cl will be there. The partial pressure or the concentration, whatever it is, that can be calculated. That is not a free thing, free variable. That's why how restriction works now in here also.
Yes.
But here, do you think there any that kind of restriction?
No,
Can
there is no
anything?
Kp.
No KP anything. Nothing is there. So it's not equilibrium. So this is a tricky question. This question, if asked in the exam, 99% student will do the mistake. Surely, if he don't know he or she, then certainly it will be wrong. Okay, but this you should try. Here is no uh, twist. This is very straightforward. Just write. Let me drink some water.
Component is 3 minus 1, 2. Phase is 2 and degrees of freedom is 2.
Phases?
2.
How?
Solid and gas.
No. Phase three. No, these things don't go with the equation. Just try to visualize things. Solid, two solids are different phase. If you have, let's say, uh, salt and sugar, if you want to mix, will they mix? Mix. You can identify with physical hands.
No.
Phases, that's it. Now, phases means if you distinguish with your physical sense, like seeing, observation, or any physical measurement, okay, by touching that, then it's obviously a different phase. So each solid substance are different phases. Each solid substance.
So why it is not for the previous question?
Which question?
Ammonium chloride.
No, this is solid. One phase, but gas will mix now.
These two are non-distinguishable, indistinguishable.
Which one?
NH3 gas and HCl gas, both
Ah,
molecules are different.
but can you distinguish?
Yes.
How? Physically.
No, physically I cannot distinguish.
The phase is that now. Phase you have to distinguish. That's why air is only one phase. Okay.
Okay.
In air, lots of gases are there, but you can distinguish that. Phase means the physical. P for physical, C for chemical. That's how I remember. You have to physically distinguish. If you can distinguish physically, that means that are different phase. Okay.
That
So
means
solid,
for solid and liquid, it is different.
no, liquid will miss. In liquid, it will depend. Here, these two liquids are non-miscible. If the
Water and alcohol,
different phase, oil
but
and
both are
water,
full.
different phase. Water and alcohol will meet. Sorry, one phase. Oil and water different phase.
Okay, understand.
Okay. So phases are three. C for components. This is constituents. Okay. C prime is constituent is chemical species. R minus R. So C prime is here directly 3. And it is a not pseudo equilibrium, it's a pure equilibrium. So C is 2. So degrees of freedom will be 1. Okay. I think it's clear, right?
Yes.
Okay. Now it's very easy. Next question. What are at its freezing point? I think this is the correct spelling. Whatever. Not right. Lots of example we have to do. Don't worry. This degrees of freedom will be clear. And one or two question generally asked from degrees of freedom. It might not be very straightforward always, but it's very easy. If you know, you know. That's it.
Component is 2 minus 1, 1. Phase is 2 and degrees of freedom is 1.
Okay, check it. So what will be the phase first? This is water at its freezing point. That means at freezing point, water, liquid, is
And
in
water solid.
equilibrium with water solid. So phase is obviously 2. It will be it
It
will
will be
be
2.
2 minus 1.
Yes,
Okay?
1.
1. So degree of freedom. That means temperature, among temperature and pressure, you can choose only one. If you choose the pressure is 1 atm, automatically temperature will be 273 Kelvin.
Yes.
That's the degrees of freedom. Or if you choose the temperature to 273 Kelvin, for having this, it will be automatically 1 atm pressure. Okay. Yeah, for each cases, already have discussed this degrees of freedom in terms of pressure and temperature.
Can you please explain the equilibrium?
This equilibrium.
Yes.
This is just
This is
liquid
not a
and
phase equilibrium.
here it's a phase equilibrium.
So why we consider restriction as 1?
No, this is not pseudo equilibrium. If you have liquid, just think like that. If you have liquid water and it's a freezing point, automatically solid water will be there. So there is a Kp or Kc or
Yes.
K. Equilibrium constant is there. It is totally different. It is absurd. This is not equilibrium. You are just trying to mixing solid iodine in liquid water and benzene. Okay,
Okay.
these things are different. If you just think like that, if you have solid iodine, will be iodine in water, iodine in benzene. That thing will be create automatically, or the vice versa.
Phase change is not occurring here.
Okay, phase change maybe here phase change is occurring. That's why two phases are there.
Yes. And there is not occurring.
Hmm. So it's clear actually.
Yes.
In general, equilibrium means equilibrium. This is very awkward example. That's why I discussed it.
Kp should be there.
Any K, not only Kp. Here Kp will not be there. Kc will be there or any other K.
Okay.
Okay. Just right. What will be the phase?
One.
How?
H2SO4 will be in aqueous, and H plus and HSO4 minus will be in aqueous.
Hmm.
H3O plus and HSO4 minus.
That is okay. Okay. So there will be a equilibrium, right?
Component is 4 minus 1, 3.
Okay. So what will be the number of phases? One. Because these things totally dissolves. Like dissolve like. Okay.
Why?
Because polar H2SO4 and H2 are polar. When you mix H2 and H2SO4, could you identify different components? In your lab,
Okay.
you use dilute H2SO4.
Yes.
So that essentially seems to be one phase, right?
Yes, one page.
So just that's why I'm saying repeatedly, don't judge this question from a textbook question. You have to just visualize. Then it will be very easy. Now components. What will
4
be the
minus
component?
1.
No. Here I have done a wrong thing. This should be the right thing,
Yes.
right? This
Yes.
totally dissolve. So C will be in only 2 minus 0, 2. No restriction. This is not equilibrium.
Why
Because
it is
now
2?
these two chemical species is totally converted to H2O plus and HSO4 minus, right?
Yes.
You have if you have 10 H2SO4 and 10 H2O, then obviously it will be 10 and 10. So you don't these things you don't have right now. You have only this. So only two components are there. Okay, and
I
this is
am
very
assuming
important.
both are in same quantity.
No,
If water is excess, then water will be available after H3O plus and H4 minus.
you are saying that okay, if water is excess, let's say here 20 waters are there, then obviously here will be 10 more H2O.
10 H2O.
If 10 H2O is there, just identify. Then how many are there? H, because this is not H2O. This is okay.
Okay.
So that means essentially here the components will be
4.
how many? Three. This
Sorry,
is
3.
okay. Three minus one, two. Clear?
Yes.
Why? This restriction, why this restriction is 1? Because you are considering this.
Yes,
This
H2O, H2O.
this is not a one-way reaction. This is equilibrium. Okay. So you can look a particular problem, particular system in various point of view, but C and P will not be changed. You can write it like this, or you can write it like this, whatever you want. That means if you have the excess H2O, then also the C will be 2. If you have the equal amount of H2O, then also the components will be 2. That will not be changed.
Okay.
Okay. So degree of freedom will be 3.
What this 3 suggests?
Okay. Temperature and pressure, first of all, 2 degrees of freedoms are there.
Yes,
And just try to understand what will be the other degrees of freedom. There are 3 degrees of freedom, right?
yes.
What can it be? Concentration of H2O.
H2SO4.
H2O. Because you see how it may be 10 H2O, 20 H2O, the ultimate C will be the same. So that is
Yes.
a degrees of freedom. Okay. Or you can not only like this, not only H2O, H2SO4 can be. So the reaction, overall the chemical reaction is degrees of freedom. You can think like that. Okay.
Okay.
But when you are saying the aqua solution of H2SO4, I'm just on trying to state it in a mathematical way. Aqua solution of H2SO4, I'm not mentioning the molarity, anything. Because for a solution, you have to mention either it is 1 molar, 0.1 molar. Do I have mentioned?
Yes. No.
That's the degrees of freedom. That is up to you. Okay.
Okay.
Okay. Similar question. This you will try with same logic. Right. What will be the answer? Is it disconnected? Can you guess it?
Phase is 1.
Okay, then.
Component is 2.
Okay. Finally, degrees of freedom. Just
3.
write it. Just write it. Okay, your degrees of freedom is correct, but phase and components are not correct. Okay, what is the reaction? H2O.
CH3COOH plus H2SO4.
Mm. Plus
H2O,
H2O.
CH.
So what will be the phase? CH3COH. COOH. This is not completely miscible in water.
But
Weakest.
it is colorless.
It is?
Colorless.
Is it? It may
It
be
is not.
colorless, but it does not dissolve totally. Like I'm giving you example, glycerin plus water. How many phases?
That I can distinguish two phases, but
How?
glycerin
Glycerin
is.
is also colorless. Refractive index is different. Any other physical parameters are there, na? You can distinguish with physical parameters also. That is also a technique. So
Okay.
that you have to understand whether it is miscible or not. That's it. How
Miscible
you
or
can
not? Okay.
how you can distinguish, that's not your business. So here obviously the phase will be 2 and the components will be
We have to do the reaction. CH3COO minus,
mhm,
H3O plus, and HSO4 minus.
exactly. So it will be 3. Okay.
Equilibrium is there.
Which equilibrium?
Acetic acid, CH3COOH2 minus and plus,
Okay, okay. So you are
because it is
saying
not completely dissolvable.
mhm. Okay, yes. So in that case it will be, so it will be C equals to, so it will be 3 minus 1. Okay.
Okay.
So degrees of freedom will be 2. Mm. Okay.
Okay.
Just let me check once more because it's H plus. No. Oh, oh, oh.
Why?
When you are considering equilibrium, the CH3COH also be there, right?
Yes.
So components will be 4. Okay. 1,
Okay.
2, 3, 4. Okay. So you are considering equilibrium, but you are not considering CH3COH. How it can be? It should not be, no?
If water is excess, then the OH minus.
That is you have already seen that will not impact. Here
One will be extra. Okay, then one equilibrium will be then. Okay.
they are not. So this effect will be cancelled out. That we have already seen.
Yes.
That we already seen. So it will be 3 and then it will be 3 minus 2 plus 2. So it will be 3. So if you want to consider the water here again, extra water, that means here will be H2O. Okay, so this is not a new species.
Yes.
So this is a new species only. This is new species, this is new species. Two species are there and there is one more restriction will be there. Okay.
Okay.
And also two restriction, not only one, two restriction will be there. So it will be no adding, no change. Am I clear? Just consider this. Okay, forget about this everything. Just consider this. So how many phase is there? One. Okay.
Okay.
Component C prime minus R. So what is C prime here?
4.
4, 3, not 4.
H2O.
Two is types of species, types of chemical species.
3.
3. And the restriction is
1.
2. Okay. Because
Yes.
so this will be also a restriction. No? So eventually one chemical species is there. So degrees of freedom will be 1. No, 1 minus 1 plus 2, 2 for this particular species. But when you consider here, so you can see phase will not be changed. Phase is as it is. Phase will be as it is 2. But the C prime, so how many C prime will be there? If you consider the water, then
5.
no, I think 6. 6. If you consider water, then you have to consider the H2O and OH minus. Both you have to consider. So then C prime
Yes.
will be
6.
6 and restriction will be now 3. One was already there and 2 from here.
Yes.
That's all. But here this restriction is not there. CH3CO minus equals to H3O plus. This is not true because you know H2SO4 will also give H3O plus. Okay. So you have to
Okay.
think very critically. Or better, don't think so much. Okay. You don't think so much. Just in this question, you can do it like this. Don't consider the reaction occurs because you know if the reaction occurs, then also the overall picture will be same. Degrees of freedom will not be changed. If the reaction occurs also, then the degrees of freedom will not be changed, right? It will be as it is. So ultimately it will be the same. So that's why you can consider this directly. So here the C is directly 3. No restriction is there. If the reaction occurs, then also because you now you can understand this phase is an easy thing. This is very easy to identify number of phases, but the
Yes.
number of components is very tricky, you can say. So that will depend on C prime and R. So here the C is 3, but when the reaction will occur, the C prime and R both will change. And again, it will be managed uh, to make it 3. So it will be 3 always, if it is 3. So due to reaction, the components will not change, you know. That should not be changed. Due to reaction, the components should not be changed. So that's why you can consider this left hand side as well. Okay, then also the degree of freedom will be 3. Here also. If you look at here, the degree of freedom will be 2. That will be 2 always. Whatever reaction condition you choose. Okay. Again, same types of question, but it is again little bit different. Aqua solution of glucose. Let me check this. Okay, sorry. Right? Aqua solution of glucose.
Phase is 2.
Then
Component is also 2. And degrees of freedom is 2.
okay. So here two cases will be there. First case, that should be
Glucose will not dissociate.
that I mentioned. Let's say it is saturated, more than saturated. Then phase will be two
Yes.
components. How many components are there? Glucose is C6H12O6 and H2O. We are not considering the reaction. After all, if you consider reaction, then also the components will not be changed. That is now clear. Okay. So for simplicity, it will be this.
Yes.
So degree of freedom 2. What was your answer?
Same.
But if it is not saturated, it is less than saturated or totally saturated, fully saturated, then phase will be 1,
Yes. It is fully dissolved.
fully dissolved. But component will not be changed. Component will be 2 always. So then degree of freedom will be 3. I think now it is now understandable
Yes. But what
gradually.
is the answer?
Both. You have to consider both.
If it is asked in exam.
In MCQ, then it will be MSQ, or it can be stated in the question whether it is saturated or not. Okay.
Okay.
If there is ambiguity in question, and there it happens in very question, many question, ambiguity remains. So you in that questions, it's totally your luck. You can say otherwise because many times happens to me as well in CSI net. I gave an answer, particular answer, but it was actually wrong. It was a correct answer, but in a different book, the answer was wrong. A complex question, which complex structure will be there? The structure of complex. I think in one book it was TBP and one book it was square pyramidal. So I marked square pyramidal and it was wrong because the answer was given as TBP. But after that,
Okay.
uh, you can question now, you can review some question by paying 1,000 rupees.
Yes.
Okay, so after reviewing, I did not review, but many student reviewed. So after review, what happens? Not PVP, not square pyramidal, they deleted both options.
What? Is it possible?
I don't know, I think they are glitch something. What happens, I don't know, but I did not get that 5 marks, whatever it is. Next, same sugar solution in an open beaker. What will be the degree of freedom?
Will it react with air?
How? With air, it will not react. Sugar solution is there. This is very common scene. You have seen lots of time in your life.
Yes.
So it will be just what will be the phase?
2.
One, not two.
If it is saturated.
No, if it is not mentioned, then why you consider the oversaturated? Generally, we don't
Okay.
consider, no?
Component is 2.
Okay. One question I miss. No, it's there. It's there. Okay. Question number 10. Hmm.
The crystal is in solid form.
Hmm. This is crystalline water. So how many phases are
A,
there?
two phases,
Two phases. How?
solid and liquid.
This is also solid.
But the yes, two solid and one liquid.
So number of phases will be
This phase is different from the Na2SO4 solid.
every solid phases are different.
Yes, yes,
Every
every solid phase is different.
are
Three phases.
different. No? That I have already said you. So that means phases will be three. But components
Minus one, two,
one, two.
three, minus one,
Exactly. So it's two. So what will be degree of freedom? Two. Oh, sorry, three. That's one.
one.
Right? Hmm. Okay. So, okay, a few more questions are there. Let us discuss. Then we'll discuss that process clustering. We have to discuss that also because this type of question, okay, it's okay, but you have to cover the things. Let us speed up. The beaker containing liquid water and sand. What will be the phase, components, and degrees of freedom?
Phase is two,
Okay. Component,
two,
how?
water and sand.
Two.
Degrees of freedom is also two.
But there is also one perspective to solve this question is correct. But if you consider the sand actually don't interfere. That, okay.
Yes,
That if you just ignore the sand, there is liquid water, and here is the sand. Sand will not physically or chemically involved with the water. Okay, it will not interact. It will remain as it is. So that's why
yes.
you can do it like if you ignore the sand, then phase will be one, component will be one, degrees of freedom will be two. So you can choose both way because you see no change because sand is not doing anything. It is not contributing uh, to any chemical exchange or physical exchange. Okay, but you can choose both. Both
If
are
I
valid.
add glucose in water, then also the same.
No, in glucose or glucose is reacting with the water. Sand is not reacting with water.
Sand will not dissolve in it.
No, never. Oh, sand never dissolve. Sand is silica, I
Yes. Phase is one that was right, and why component is one?
We are not considering the sand.
Okay.
Then, not only sand, this type of species you can ignore.
Those are non-reacting species.
But if you ask my opinion, I should say this should be followed. Then probability of mistake will be less.
Okay.
Okay, now, okay, the same question, same type of question. I think this can be done. There is no tricks, anything. So what will be the number of phases?
Three.
Three. Correct.
Sorry, H2O in gas.
Yes, two solids are there and one gas. Gas will be dissolved.
Gas will H2O will not be in liquid.
No, it is written gas now.
Okay.
So phase three,
Component is 4 minus 1.
4 minus 1. So 3. Now it is clear, right? So it will be
2.
2. Okay. So last question. This after that we will discuss something different. So I'm giving a system which contains NaCl solid, KCl solid, Na plus aqueous in water obviously, uh, K plus aqueous, Cl minus aqueous, H2O and H2O gas. So now calculate the number of phases and degrees, components and degrees of freedom. Phases is easy, I think.
Phases is 4.
How?
2
Two
solid,
solid,
1 gas, and
one
1 liquid.
liquid, one liquid. Yes, four. Great. 10 components.
3. Sorry, 4 minus 4 total.
That's how?
Na plus, K plus, Cl minus, and H plus.
Na plus, K plus, Cl minus, H2O.
Yes.
And restriction.
1 equilibrium.
Okay. Or you can think like that. That's why I'm saying these components will not be changed. You can consider that dissolved also. If you see, this will be Na plus Cl minus, K plus Cl minus. Okay. And H2O is?
H plus OH minus.
No, that we will not consider. That we know. Because considering that, that will not make any change.
Liquid to gas.
That's it. So here will be 3. So what will be the degrees of freedom? 1. Okay.
What is the significance of it?
Probably the temperature, anything, temperature or pressure, anyone. Both you can't. This is a complicated situation now.
Okay.
Okay. So now this type of questions, I think it's clear now. You can try this type of question. If there is any doubt or uh, if you start in any question, you can ask me. Okay? But I think lots of example we have done today. This type of question. Now we
Yes.
should go for the type of question. It will be now question number 3. So phase diagram is clear.
Yes. But the triple point is not clear.
Okay. Okay. So in this question, we will discuss the phase diagram of sulfur. Then I think it will be clear. Okay. Before sulfur, okay, for water. Water, how it looks? Let me draw. It's negative slope for water.
It will be straight line.
Ah. So this part is solid. Okay. So this is our
Okay.
solid. This is our liquid. And let me choose a different color. This is gas. Okay. Is
It
it
will be
clear?
overlap.
Yes. That part I sorry. Okay. This part I will discuss. It is not overlapping. Okay, I'll say it. But uh, before that, I think it's there. Okay. Up to that
Yes.
part. Okay. So it is not, I think, visible. Let me connect it again. Yes. Okay. So this is solid. This is liquid. This is gas. Okay. And this point is called triple point, which is okay. This is if it is for water, I think for water it's slope is negative or positive. Slope is negative. This is negative slope, right? So this is for water. Yes. This is for water. Let me check the values because these values I don't remember. On phase diagram of water. Yes. Hmm. So this. is the triple point. Okay. So this value is 0.006 atmosphere, and this value is 0.0 273.01 Kelvin. No, one more. Let me search it for. It's correct formula. Hmm, it's correct. It's correct. Oh, okay. Triple point of water. Yes, it's correct. It's 1.6 Kelvin, and this actually okay. So this is the triple point. Okay. Okay. So now, if you choose, is this diagram is clear?
Yes.
Okay. So now, let me name this point. This is, let's say, O. This is, let's say, A. Actually, it's actually like this. So it's actually to be. Let me draw it correctly. Like this. Okay. So O, let's say it is A, C, B. If these are the points, this is important. Here I did not draw, but it will be like this. After the A point, actually here, after the point A, after the point it will be gas. No, that will be gas, but the thing will not be like same. It will be mixed like this. Okay.
Okay.
How? I'm just explaining this. So I think this is now clear. So these areas, solid, liquid, and gas, these areas, what are the points in this phase diagram? Hmm. First, areas. How many areas are there? Important areas?
Three.
First, three. First is AOB, which is gas. Correct? Means area under AOB.
Yes.
This is gas, right? So in gas, what will be here? The component is one because this is pure substance. So component is one. So now what will be the degree of freedom? C minus P plus 2.
Phase is one. Phase is three.
Phase is 1 at this area. Only
Yes.
gas
At
is
this area
there.
one.
So it will be 1 minus 1 plus 2. So degrees of freedom 2. So you can see temperature, pressure, both you can change, right?
Yes.
Both you can change. 2 degrees of freedoms are there. You can, if you choose this point, then the pressure and temperature is different. Here also pressure and temperature is different. 2 degrees of freedoms are there. You can choose both. Okay.
Okay.
So AOB is clear. And next is COB. COB is solid. for all these three, COB and another one is AOC. AOC is liquid. For all these three, degree of freedom will be 2 because phase is 1. For any area, degrees of freedom will be 2 because phase is 1. Okay.
Okay.
Now lines. Lines are like this: AO, CO, BO, these lines. So these lines AO means this actually signifies the equilibrium of liquid and gas, because you see in line liquid and gas in the equilibrium.
Yes.
Okay. Similarly for line BO, the
Gas and solid.
solid and gas, correct, and for the line CO, the liquid, solid and liquid. So for each lines, you can see for each line the components will be 1, phase now 2. So degree of freedom will be 1 minus 2 plus 2, so 1. So you see, you can fix only one variable, either pressure or temperature. The other one will be automatically fixed. Let's say here in this line, if you choose this point, this temperature, if you choose,
Pressure is automatically
automatically the
defined.
pressure will be fixed. You can't choose different pressure, then it will not be in that line. Okay, automatically this temperature will be fixed. So
Yes.
that's why degree of freedom is 1. Or the vice versa. If you choose the pressure, the temperature you now can't choose. Okay. So is it clear now?
Yes.
Okay. And the next one is point. Only one point is there, that is O, where the solid, liquid, and gas are in equilibrium. So component is 1, pressure is phase is 3. So degree of freedom will be 0. So you don't have any degree of freedom. This is only one value. You can't choose. Pressure, temperature you can't choose. That is fixed. So clear it.
Yes.
Okay. So that's why it's called the triple point. And this A and this after that point A, there is no distinction between liquid and solid. What happens in general when you pass? Let's say I'm just erasing this. Okay, ignore it. Let's say when you isobarically, if you move in this direction, that means you are increasing the temperature, and at a constant pressure, that means it will change from solid to liquid. But at a particular point, the solid liquid coexist, which is called the equilibrium. The solid is transforming to liquid, and liquid is also transforming to solid. This is called phase equilibrium, right?
Yes.
And here also you will have another phase equilibrium between liquid and gas. But after that A point, there is no phase equilibrium. Okay. Liquid and gas both will behave like same. This is called the uh, special type of fluid actually. That's why it's not called liquid or gas. It's called fluid. Here it is called fluid. Okay.
Supercooled liquid.
No, 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 not super cool liquid. It's fluid because it suddenly it is solid. After some time it will be gas, something like that. Continuous exchange is occurring between solid and liquid happens. So this point is called the critical point, and the pressure of this critical point is called critical pressure, and the temperature of the this point is critical temperature. So after that critical temperature and critical pressure, there is no liquid and gas conversion. The liquid and gas will be coexist. Is it clear? I It might be something very strange to hear.
Yes.
Okay.
It will coexist means there is the equilibrium between those phases.
No equilibrium. Sorry, no equilibrium. You will see suddenly it is liquid, then it will be converted in water, solid, solid gas, then also from gas to liquid. It's always be there. It is not equilibrium. In equilibrium, both coexist. It will not coexist. Continuous transformation will be there. There is no boundary line. Okay,
Okay.
so this is actually very dedicated research topic, so this is not here to discuss, but I think it's now understandable. Okay,
Yes.
and liquid, 1 minute. It is connected. This Bluetooth it is connected. Okay, okay. So now, so this is our total phase diagram. Now I think it is totally clear. For carbon monoxide, its values will be effectively different, but for carbon monoxide, the main change will be this slope is different. Okay, this we'll discuss from Clausius-Clapeyron equation. Okay, so how the phase diagram will be looking for carbon monoxide? I think phase diagram of water is clear, right?
Yes.
For carbon monoxide, everything will be same. Mhm. Something like this. Oh, this is not parallel. Huh. So this is TC and this is PC. Okay, and this area is totally gas, carbon dioxide gas. This is liquid. This is solid.
Every phase diagram is same.
Same. But the point will be different. The value. This value will not be same for the uh, water. Here the value is, this is 4.58 mmHg. This value is 0.0075 degree centigrade. Okay, so degree centigrade. Huh. And this PC and TC, PC is 218 atm, TC is 374 degree centigrade. This is for carbon monoxide. Okay,
Okay.
but our question was for sulfur. Here also you can calculate the degrees of freedom. In the areas, phase is only one, so obviously degrees of freedom will be two. In the lines, the phase is two, so degrees of freedom will be one. And in the dots, that point, triple point, the degrees of freedom will be zero, because all three phases are there. Okay,
Okay.
so it is O, A, B, C V. And this I forgot to say. Let's say if you extend this, so this is called our supercooled liquid. Okay, metastable phases these are, because this is uh, you are just this you are extrapolating this line. So here the solid must be there, but if you solidify very slowly, find some small change, then liquid will be remain same. It will be liquid because it will not understand that the temperature is already beyond less than 0 degree centigrade. That's why it will be liquid, but it is called supercooled liquid because the temperature of the liquid is less than 0 degree centigrade. Okay, so
The liquid will not understand.
yes, the system should not be understand how the phase change occurs, because when are you cooling down the temperature, cooling down the water, the organization occurs. Okay, the molecular speed, the molecular velocity of molecules, water molecule decreases, and the arrangement appears. And then for to make the structure of ice has a particular structure, tetrahedral structure. That structure uh, water has to make. So that's why he at 0 degree centigrade during phase transition, what happens? The molecules of water actually rearranges and it makes a shape to ice. The structure will be like ice, the solid state structure. It will be tidal things, right? That structure happens. That's why it's not only for ice in every cases, for every solid transformation, this structure formation is there. So that's why this freezing occurs. That is called freezing. When it breaks, it's called melting. Okay, but you are decreasing the temperature very slowly. Very slowly. It actually don't understand the temperature is decreasing. That's why it will not change their structure. The temperature is decreased because temperature is the measure of the average kinetic energy that is decreased. But it did not understand the system that you have to rearrange your orientation and structure so that you can look like ice. Okay, that's the problem. That is the concept of metastable liquid. So that's why it will remain as liquid. It will look like liquid, but temperature of the liquid will be less than 0 degree centigrade.
How can I put it solid?
Just said you can just give a knock on it. Any small perturbation from outside, then it will suddenly understand that, oh, it is minus, it's less than 0 degree centigrade. So I have to rearrange it. That's it. It's like that you have make the water hypnotized. That's why he did not change to solid. When you just knock, the hypnotizing break, and it will just rapidly convert it to the liquid, solid. Because the entropy of you can see this is entropy of solid in that case is decreasing, increased. That's right. Okay, is it clear?
Yes.
So this is experimentally verified, and suddenly it forms in freezer also. When you make water to cool in basically in summer, sometimes it happens.
In normal freezer.
Yes, if you are lucky enough, you can see.
And if I disturb it just once,
Suddenly it will. In YouTube, there are lots of videos you can search.
okay.
Just you can give a knock. Total water bottle will be converted to ice in fraction of second. Okay, so and that is possible not only for ice, for any here also. Uh, you can extrapolate in this way. That's also you can do. I don't know that is experimentally achievable or not, but theoretically you can do.
Why stretch this line only? AO line.
No, you can extrapolate any line. But this, I think this liquid, this is more physically possible. Other, I don't know whether it is physically possible or not. Super hot liquid is no, that is physically possible. That means that is liquid, but the temperature of liquid is greater than 100 degrees centigrade. That is
If I
possible.
knock it, it will vaporize.
Exactly. Same phenomenon. Okay.
This is research topic.
Yes, but this is well known. This is not very new thing. This is quite awkward, but this is not new thing. But we have to discuss the phase diagram of sulfur. That was our question. Okay. For sulfur, there are four phases. Okay. For water and for CO2, for most of the cases, there are three phases we discuss. But in sulfur, in general, there are four phases, which are
Solid, liquid, gas,
two types of solid: rhombic sulfur,
monoclinic.
monoclinic sulfur. Okay. So how the phase diagram will look? Just this is very important question again. I'm just trying to draw. I don't know whether it will look good or not. It looks like this. Just let me draw the areas. This area is sulfur gas. This area is sulfur liquid. This area is sulfur monoclinic. And I think oh, same. This is sulfur rhombic. So this is the phase diagram. Okay. So here also in any phase, there are any area. You can choose any area. Let me name it. A, B, C, D, E. This point is, let's say, G, and if you extrapolate here, see, you can extrapolate anything. F, H, E, F, G, H. Huh. Okay. So these are the points. So you can see here these areas. Areas means this SG area, SL area, or SR area. In these areas, the number of phase is one. Correct? Is it understandable?
Yes.
So in the areas, just like before, in the areas, so let me write it, otherwise it can be confusing. First, I'm writing the areas. First area is A, B, C, D. This A, B, C, D area, right? So this is gas. Second area is uh, G, E, C, D, G, E, C, D, G, E, C, D. This is sulfur liquid. The third area, this area, G, E, B, A. So G, E, B, A. So this is rhombic. And this area, BCE, this BCE is our monoclinic. Okay. So in every areas, the phase is one, component is always one. So degrees of freedom will be C minus P plus 2. So it will be 2. Correct?
Yes.
Okay. These are the areas. Now the curves or lines, whatever you want to say. What will be the curves? First, you can see here AB, BC, CD. First, AB. What is happening at AB? AB curve is suggesting this transition, right?
Rhombic to gas.
Rhombic to gas. So, okay. So, this is called sublimation curve of rhombic sulfur. It is sublimation because this is direct solid
Yes.
to
Solid to gas.
gas. Next, second line. Let's say this. This is clear. CD. This is just liquid to gas. So this is our just boiling or vaporization. Okay.
Yes.
Next is this. This is our EG. EG curve. At EG curve, what is happening? That solid, uh, rhombic to solid,
Rhombic to solid.
solid, not solid, sulfur liquid. This is fusion curve, right?
Fusion.
Of rhombic sulfur. Okay. Next, the fourth. Which one we can choose? This one, BC. Here also, this is also sublimation because this is actually representing monoclinic to
To
sulfur
gas.
gas. So this is also sublimation
Sublimation of monoclinic.
monoclinic sulfur. Okay, BC have next is okay. This is EC. So EC is essentially monoclinic and
Monoclinic to liquid.
sulfur liquid. So this is also our uh,
Fusion of monoclinic.
fusion, not fusion, melting or fusion. Fusion means melting, right? Yes. Sorry. Fusion of monoclinic. And one more left, this one. Okay, BE. So this is our sulfur monoclinic to sulfur rhombic. So this is called, what does it call? This is called transition between two solids. Transition curve between two solids. Okay.
Okay.
So for all these curves, for all any curve you choose, components is essentially one, but phase is two. That's why the degrees of freedom will be c minus c plus 2. So it will be 1 minus 2 plus 2. So it is 1. Clear?
Yes.
Same like earlier. You see, for each state you can see that if you this SG, it is also undergoing three transition. Is SG to SL, SG to SM, SG to SR. SR also going to 3, SL, SG, and SM. SM also going to 3. All states are undergoing three transitions. So that should be, because there are four states are there, and you know for transition you need to two state. Transition occurs between two states.
Yes.
So it will be 4C2. So 4 factorial by 2 factorial, 2 factorial, so 6. So that's why you obtain 6 transitions, 6 curves. Before it was 3C2. So it was 3 factorial by 2 factorial, 3. That's why you obtain 3 curves only. Okay. Is it clear?
Yes.
Okay. So next is points. How many points are there?
4,
That's also you can calculate. Points means 3 states should be remain at the same time, same point. So
3.
before it was 3C3. That's why it was 1. Correct?
But here is 3 point.
Here 4C3. 4 states are there, right?
Yes.
So it will be 4 factorial by 3 factorial, 1 factorial. Not 3 factorial only. So it will be 4.
4.
Which 4? Point E, B,
B, C, F.
F. So for point B. So at point B, which states are coincides? This is SR, SG, and SM.
Rhombic gas and monoclinic.
So SR, SM, and SG. Next is point E. And at point E, which states are there? Which phases? SR, SL, SM. And at point C, it will be SL, SM, SG. So for all three cases, 3 points, components 1, phase is now 3. So degree of freedom will be 1 minus 3 plus 2, so 0. That is the definition of triple point. So 3 triple points are there. One more triple point is there, that is at F, where SM, just see here, SL, SR, and SG. SL, SR, and SG. But this is metastable point. Just like previous one, we obtain this by extrapolating that curves. So every cases you have to change that gas such that it does not understand, oh, I have just converted to SM. So that's why it has extrapolated that DC line. This is just AB line and this is G line. Then it can create a metastable tipping point, but this is totally hypothetical. Okay. So eventually, if you ask that how many tipping points are there in phase diagram of sulfur, then the answer will be four, not
Three.
four, it will be three.
One is
Okay.
metastable.
Metastable, and that is totally hypothetical. Okay, that is not one line may be extrapolated, but three lines will be extrapolated, and that will create a hypothetical point, metastable point. That's possible. Okay, okay. So I think it is clear totally. So today it's not possible to discuss that Clausius-Clapeyron equation due to lack of time. Better we can discuss two more example of this. Okay, next class
Okay.
we'll discuss. How can we break the page? 1 minute. Mm, mm, okay. So question number 14. There. Okay, now you can do it. Liquid water and water vapor in equilibrium at 1 atm. So now calculate component, phases, and degrees of freedom. Question is clear?
Yes.
No.
Phase is 2.
Phases 2, because this is just liquid water and water vapor. That means this line, this line, AO line, this AO line, correct?
Yes.
Just how can I bold it? Okay, this is bold already. This line, this line, this AO line, correct?
Yes.
Already we have calculated this is 2, phase 2. Now next is component. Component 1, no. Component is 2.
2 minus 0.
2 minus 0.
No, 1.
So because this is this already.
Equilibrium.
So one restriction is there. Another one restriction is there. This.
SR is 1 atm.
Yes, this is another condition. So C is 0. So degrees of freedom will be 0. You can see, here degrees of freedom is 1. That means you can choose either pressure or temperature. You have already chosen the temperature. Pressure is 1 atm. So obviously there is no degrees of freedom left. The temperature will
Yes.
be predefined. So that's why. Okay. Okay, so this will be our last question. Now consider this reaction we have already considered, but now again we can consider it. This part we did not consider before. This was our starting question. This no this no. Here this the same. Just I have here also have considered the in between transition state. This vapor, not transition state. This vapor phase change. So now you have to consider, first you consider this is not equal. This restriction is not there. Then the number of phases will be
2.
2. Exactly. Components 4 minus 2.
4 minus 2.
So it is 2. And so degrees of freedom will be
2.
great. But if there is one more restriction that pressure should be equals ratio,
One
then
restriction will be added.
one restriction will be added. So it will be just 4 minus
Yes, 3.
3. It will be 1. So our degrees of freedom will be now
1.
okay. So this type of question also can be asked. So I think each and every type of question we have discussed. Yes, and
Yes.
also yes. Okay. So let us stop today. I think lots of type of question we have discussed, but the Clausius Clapeyron equation we have not discussed. That will decide this slope. These slopes will be decided. How I am writing these slopes. I'm not writing ad hocly. These slopes will be guided by this dPdt, obviously. If the dPdt is positive, then it will be like this. Correct? dPdt for solid to
Yes.
liquid. If dPdt is negative, then it will be like this. So these things we will discuss in the next class. Clausius Clapeyron part. This part also discussed in class as well, but still we will discuss and we will also solve few questions from Clausius Clapeyron equation in next class. Okay, then probably it will be this phase part. I think it will be clear. Okay,
Okay.
so we stop here. If you have any doubt, then you can ask. I know this is totally confusing. Just revise it. Just go for it. Just I'll share the PDF and just go for it. Uh, it is confusing. I agree. But if you practice little more, then I think you can do it. Just go solve the previous years. I think now you can solve. You have get some confidence, I guess.
Yes.
Some exception will be there that you can't handle. That you have to accept. But 90% cases you will be correct.
Where do I found the problems?
Previous year question you don't have the previous year question set.
No.
Okay, I'll find if I get. I lost actually. I had all previous year question from NET-GATE, but I have lost that.
Can you
Okay,
please share?
yes, yes. Okay, okay, okay. I'll find it. Okay,
And the notes for this part?
these notes I have written today. This one.
No, no. You said when you come home, you will.
For this total thermodynamics, right?
Yes.
Okay, that I will say. Yes, surely. You just remind me in WhatsApp tomorrow or day after tomorrow.
Okay.
Okay. So now let me stop sharing first. Okay. This PDF I will share. Okay. We'll join again. But in next week, I think the class will be on Saturday because Sunday I will be returning back. So I will be busy. So uh, I will mail them. Saturday from 4 p.m. I will take the class.
Saturday 4 p.m.
Hmm. Do you have any problem?
Yes.
Okay. Then what is your preferable time?
3 p.m.
Okay. Saturday 3 p.m. I will mail them.
Okay. Thank you.
Okay. So we'll meet again in Saturday. Thank you for joining.